right. Okay, so for the next example, say if we wanted to solve negative sine squared theta plus 7 sine of theta minus 3 equals 0, where theta is between 0 and 2 pi. Oh, sorry about that. Okay, so I'm just going to go ahead and replace sine of theta with a variable, replace it with x or y or anything. So replace sine of theta with your variable, so that gives us negative x squared plus 7x minus 3 equals 0. Just to get rid of that negative coefficient, I'll multiply both sides by negative 1. That gives you x squared minus 7x plus 3 equals 0. You don't have to do that, but I just like to have my lead coefficient be positive. All right. Now with this one, you can't factor it all that neatly because you can't have an x plus this, x minus that kind of jump out at you. So you can actually use the quadratic formula for this. Factor using the quadratic formula. Okay, so you know here your a is equal to 1, your b is equal to negative 7, and your c is equal to 3. Okay, so we know that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that gives us negative 7 plus or minus the square root of negative 7 squared minus 4 times 1 times 3 all over 2 times 1. Okay, which is equal to 7 plus or minus square root of 49 minus 12 divided by 2, which gives us square root of 37. So that means x is equal to 7 over 2 plus square root of 37 over 2. And x is equal to 7 over 2 minus square root of 37 over 2. Might as well go ahead and finish this one up. 7 plus or minus square root of 37 over 2. Okay, so those you wouldn't have been able to factor out that easily. Okay, but you can do the exact same thing. Okay, so here we're going to replace our x with sine of theta. Okay, so that gives us sine of theta equals 7 over 2 plus square root of 37 over 2. And sine of theta equals 7 over 2 minus square root of 37 over 2. Okay. So if you just plug that into your calculator, sine of theta equals 0.45 8619. Actually, I think these should be switched around. I think I wrote them under, that should be under this one. 458,619, and this one should be 6.514. Nope, 541,138. Okay, 54138. Get that decimal point and fill it in a little bit. Okay, so you have 6.54138, and you have 0.0458619. This one, you can automatically just get rid of it, because sine of theta has to be between -1 and 1. So no solution, since sine of theta has to be between there. Okay. Now to solve for this one, you just apply sine inverse to both sides. Okay. So remember, it's also sine theta is positive, and quadrant 1 and quadrant 2. Okay, so if we apply sine inverse, actually let me just write that in. Okay, apply sine inverse to both sides. Okay, so the sine and sine inverse would cancel out here. So you have theta equals sine inverse of 0.458619. Okay. Now once you plug that in, that will give you your quadrant 1 value of theta. So theta would equal 0.48, and that's in quadrant 1. Now in quadrant 2, theta would equal, remember you have your reference angle, so it would be pi minus your theta. So pi minus 0.48. So if you plug that into your calculator, you will get 2.67 in quadrant 2. Okay, so just like before, even though you got a positive value, you have to think, okay, now where is sine always positive? If it's always positive in 1 and 2, then we know we have to find both of those thetas. Move that over a little bit. All right, so any questions on that one? Okay, leave that up for a few seconds. All right, so let's say for our next example. If you want to solve 3 cosine squared theta plus 6 cosine of theta minus 4 equals 0, where theta is between 0 and 2 pi. Okay, so again, first thing I'm going to do, just to make it easier, to replace cosine of theta with a variable. Okay, so that gives us 3x squared plus 6x minus 4 equals 0. Which once again is not a really neat factor. Okay. So again, we're going to use the quadratic formula. Okay, so you know your a is equal to 3, b is equal to 6, and your c is equal to -4. Okay, so your x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a, which is equal to -6 plus or minus the square root of 6 squared minus 4 times 3 times -4 all over 2 times 3. Okay, so that means x is equal to -6 plus or minus, that comes out to be square root of 84 divided by 6. Okay, so square root of 84 isn't a perfect square, so you know you're going to get an irrational number somewhere. So if you just plug that into your calculator, you end up with x is equal to about 0.527525, and x is rounded to about -2.52753. Okay, now once you get here, you just replace your variable with cosine of theta. Okay, so that gives us cosine of theta equals 0.527525, and cosine of theta equals -2.52753. Okay, so what's the first thing that jumps out at you? One of those should disappear. Yep, because it's out of our range of -1 and 1. Okay, so that one automatically, you know you don't even have to bother with it. So it's no solution since cosine of theta has to be between -1 and 1. Okay. Now here we know cosine theta is positive. Okay, so we came out with a positive answer, so we know it's cosine of theta is positive in quadrant 1 and quadrant 4. Okay, so now we just make it, well, apply cosine inverse. So that gives us theta equals cosine inverse of 0.527525. Okay, so you plug that into your calculator, your theta is going to equal 1.02, and that's in quadrant 1. Okay. Now remember, in quadrant 4, that's when we have to use our reference angle. Okay, so theta is going to equal 2 pi minus, I guess you can say, your theta, which is 2 pi minus 1.02, which is 5.27 in quadrant 4. Okay, so we have 1.02, and 5.27 is your final answer. All right, so any questions on that one? All right, so some of them you can factor out using the more traditional methods, but some of them you will have to kind of tiptoe into the quadratic formula. All right, leave that up for a few more seconds. All right. Okay, so let's say if we wanted to solve 2 times cosine of 2 beta plus 8 times cosine of beta minus 3 equals 0. And that's where beta is between 0 and 2 pi. Okay, so for this one, they threw in a cosine of 2 beta, which throws our plans off a little bit. Okay, so you don't want cosine of 2 betas, you just want cosine of beta. So if you have just a cosine of beta, all you have to do is remember that cosine of 2 beta is equal to 2 cosine squared beta minus 1. It gave us a square, but it reduced it to just cosine of beta. Okay, so one of our double identity rules. So that means our 2 cosine of 2 beta plus 8 cosine of beta minus 3 equals 0 becomes 2 times 2 cosine squared beta minus 1 plus 8 cosine of beta minus 3 equals 0. Okay, so if we go ahead and distribute that 2, we have 4 cosine squared of beta minus 2 plus 8 cosine of beta minus 3 equals 0. And now we just have to combine all of our like terms, so really just the negative 2 and negative 3. So you have 4 cosine squared of beta. Clean that up a little bit. There you go. Plus 8 cosine of beta minus 5 equals 0. Okay, which really gets us back to what we were starting to get used to. Just nothing but cosines. Okay, so now we can replace our cosine with a variable. Clean that up, square it up a little bit. Okay. So now we replace cosine of beta with a variable. Okay, so we have 4x squared plus 8x minus 5 equals 0. Okay. So just so happens that one factors out pretty neatly to 2x plus 5 and 2x minus 1 equals 0. Okay, so that means 2x plus 5 can equal 0. Or 2x minus 1 can equal 0. Okay, so if we subtract 5, then divide by 2, x can equal negative 5 over 2. If we add 1, then divide by 2, x can equal 1/2. Okay, and now we just replace our x with our cosine of beta. Okay. So we have cosine of beta equals negative 5 over 2. And cosine of beta equal to 1/2. Okay. So we know negative 5 over 2 is just negative 2.5, which we already know. Once it's lower than negative 1, we just get rid of it. We don't even need it. Okay, so no solution, since cosine has to be between negative 1 and 1. Okay. Now cosine beta equals 1/2. 1/2 is positive. So we know that it's positive, cosine is positive in quadrant 1 and quadrant 4. So quadrant 1 and quadrant 4. Okay, so we know in quadrant 1, cosine of beta equals 1/2 is true for beta equals pi over 3 in quadrant 1, and beta equals 5 pi over 3 in quadrant 4. Remember in quadrant 4, it's just 2 pi minus theta. So it would be 2 pi minus pi over 3. That's how you got your 5 pi over 3. Okay, so those would be your two answers. All right, so any questions on that one? All right. Okay, so for our next example, let's say if we wanted to solve cosine to the third of negative x times tangent squared of x plus cosine to the third of negative x equals square root of 3 over 2. Okay. Now the first thing you want to do is look at that negative inside of there. Okay. So remember two things. That the cosine to the third of x is the same as just saying cosine of x to the third power, and cosine of x is an even function. Okay, so by being an even function, cosine of negative x is equal to cosine of positive x. cosine of negative x is equal to cosine of x. Okay. So if we were to rewrite this, that means cosine to the third of negative x. Remember, that's just equal to cosine of negative x to the third power. Since cosine of negative x is equal to cosine of x, that's just equal to cosine of x to the third power, which is equal to cosine to the third of x. So you can replace this cosine to the third of negative x with cosine to the third of positive x. Oh, sorry about that. Okay, so that gives us cosine of third to the third of x times tangent squared of x plus, let me kind of separate that a little bit, cosine to the third of x equals square root of 3 over 2. Make that plus sign a little more visible. There we go. Okay. Now if you wanted to, you can make your functions into variables, or you can just factor out cosine to the third of x, since it appears in both terms. Factor out cosine third of x. Okay, so that gives us cosine to the third of x times tangent squared of x plus 1 equals square root of 3 over 2. Okay. Now going back to our Pythagorean identities, we know that tangent squared of x is equal to, well, tangent squared of x plus 1 is equal to secant squared of x. Okay, so that means we can replace this with secant squared of x. So you have cosine to the third of x times secant squared of x equals square root of 3 over 2. Okay. Now another thing we can remember is that secant squared of x is equal to 1 over cosine squared of x. So that means this can become 1 over cosine squared of x. So you have cosine to the third of x times 1 over cosine squared of x equals square root of 3 over 2. Okay. So it would be the same thing as if you had x to the third times 1 over x squared. The x squared will cancel out and leave you with just an x. So same thing here. This cancels out. 2 of these cancel out and leave you with just 1. So that's just cosine of x equals square root of 3 over 2. Okay. So we know that cosine is positive in quadrant 1 and quadrant 4. So that means this would be true. Cosine of x equals